Well, at least Streamlabs appears to be working again. Um, I thought I'd give it a shot, and not much happening. Just wanted to test it, see if it's working. And yeah, I just want to give a little update on the situation. Um, I'm doing the new rotors because, for one thing, I haven't populated all the magnets in here yet, but I was on the live stream the other day and I was talking about I've still got the middle magnets to put in, and letting it dry out. As it's drying, I noticed there's some fractures appearing, just very small fractures there, which is no problem, and a little one there, which I can sort out with some acetone later on. I actually caught that with my nail or something anyway, but no big deal. I tell you, the other drum that I had to dismantle a drum, right, to get the magnets out to put in the new drum. I had one rotor with the old configuration, that's without the rectangular magnets on the edge there, and I was trying to get it apart, and I was explaining that I would use a knife and I'd roll a knife around it and try and split it down the middle to get my magnets out. Long story short, it was a fail. I couldn't get the magnets out. It's that big and strong. So it kind of reassured me that it's not going to fly apart. These are very strong. I just could not get it apart. I mean, I literally had a screwdriver jammed in the side there, and I was banging it with a hammer and prising it, trying to force the other one apart. It just wouldn't come apart. And I'm thinking, God, that's really strong. And there's no way that thing's going to fly apart and hit me in the face. Basically, it's the same as one of these. This is the other one. And yeah, they were just absolutely really, really strong. You just can't get them apart. So what did I do to get the magnets out? Because I would have manually had to ream out every single hole, and then try to force the magnets out. And I thought, bugger that. So what did I do? I stuck it inside that container in there, and I just melted the whole thing down with acetone. So it took about a day and a half to melt down one of these completely, and I ended up with a great big plastic blob, a big ball of plastic in the middle with all the magnets all sort of congregating together. They were all pulling themselves towards each other, and yeah, I recovered all of the magnets out of one of these. Anyway, I got all the magnets out. It was a sticky mess. You would not believe the mess. Well, there's a bit of plastic in here just to show you. Sorry, it's my ashtray. Look at that part. That was what stuck to a plastic bag. Yeah. It was absolutely. Anyway, I melted it all down because I'm going to reuse it. I'm not going to waste the plastic. So I ended up with three. I filled up these. I've ended up with three of these full of plastic. I'll show you what I mean. I'll take the lid off. I don't want to spill it. So everything was melted down into that. So I made my glue, my plastic glue, and there's another one. So I melted it all down into plastic glue, which I can use in my syringe thing. I'm doing repairs and things, so I'm not going to waste it. It's going to get recycled. So I'm recycling all that plastic basically, and I'll stick them all there for when I need them. Right, so yeah, all that plastic's going to get reused at some point. I usually use it for doing repairs or gluing ABS plastic together when I'm trying to bond two bits of, when they get splits. Like this like that other one I was just showing you, that's the one here that's got a like fracture in it. I'm going to leave it to dry out until it opens up a bit, then inject some plastic into the gap, and then it'll make it good. But it's going to be fine anyway. These things just don't want to come apart, as I found out. Very strong stuff. Anyway, it is. ABS was invented, I think. Oh, I'd have to look it up in the wiki, but apparently it was invented. Was it in the 60s or something? when they brought the new toys out that were made in ABS. The original toys were made out of some kind of Bakelite, or was it before that? It might have been in the 50s, I'm not sure. But we used to use Bakelite, and then ABS plastic was introduced as an alternative, and it was much stronger and more resilient. So what else is the news? Yeah, I've been thinking about this, about the magnets and the coils on my. So I've got it running at the moment. I've just been doing a test run. So my bobbins. Let's see the bobbins. Oh, let's get one of these other bobbins to show you what I mean. Now, when you have the equal opposite reaction that normally causes the drag, what's happening is that there's a reluctance between the coil on the side that's being actuated by the rotary magnet. So as the rotor passes and it leaves, there's some reluctance in that it pulls back on the rotor and to slow it down. And I'm thinking, actually, there are other things I can do, which I did previously on my other earlier builds, but I kind of forgot about them. You know, there's certain things that you do try and then you forget about. But one of the things that you can do is to have a U-shape coupling on the exit point, so that what my exit coil is basically doing that anyway. So when I have my exit coil, get one of these coils just a minute. So when my exit coil is basically at the bottom as it's leaving, I'll do it on that side. So what's happening is I send him a signal. The power generating is stored in my delay line circuit, which is not here, and then it sends a pulse through the exit coil, which basically pushes the rotor away to counteract some of the drag on the system. Now the other way of doing that is to also induce some flux redirecting through the system, so that you have a core through there, and then it goes a U-shape coming back through the exit coil. So I'm thinking about actually going to that and doing that at some point, but it's going to be a little bit fiddly to do really. But I have been making some designs, and I plan on using some steel bars. Basically, let's just stand this flat. Just give you a rough idea. It's not exactly, there's nothing to scale. So what I would have is some pieces of steel bar. These aren't the right ones. Where's the other ones? These are the ones that are 25mm. These are a lot longer. So I'd have some coupling bars on the back somehow, which will probably set up, and then have some of that flux. Alright, it's falling in the hole now. Divert it down the core of the other one, so that we can amplify the counteractive force to overcome some of the drag. So that's, yeah, kind of what I'm thinking about at the moment, as well as I actually have enough filament to print two more magnet things, because I didn't realize actually how much filament I had left, and I have a tiny little bit. Oh, you can't see very well. Hang on. I have a tiny little bit. It's not a lot, and yeah. So I've got to order some more next week. But there's enough to do another magnet drum, which I'm doing at the moment. I made some adjustments to my settings because to try to overcome that problem of the splitting on there. So hopefully this other one won't split. You know, I increased the extruder so that it pushes more plastic through at about an extra millimeter. So adding an extra millimeter, I think it was something like 30mm or some second, I don't know, some seconds, so many seconds I think, I don't know. But anyway, I just added 1mm to that value. Hopefully that should sort that out. We'll find out later. Know what else is going on? I just moved my trigger coils that were on the front there. I just moved them onto the top because this section is not generating any power as such. Well, it's just sending electrical signals to the signal trigger circuit. So I've got the trigger circuits going through that wire for the pulse drive circuit, which is down there, and the pulse coils underneath, directly opposite. And I've got the other trigger circuit on here, which is for this AC switching, which is not actually turned on right now because I'm just bypassing it with this switch right now. But But at the moment it's only drawing 360 milliamps to drive it, and it's at about 3,200 and 3,238 RPM, and 73.3 milliamps going into 8.52 volts DC, which is up there. Well, you see 30 milliamps going in, because I think that the current sensing bridge that's on that thing might not be that accurate, but there's some losses anyway, because the relay's triggered so a bit early, so that's probably sapping some of the juice out of it. So there's not a lot happening right now, but because I've got to order some more filament next week, and I have got some design improvements. I plan on extending this because of the extra drums I'm making. I want to make this twice as long and have an extension which will have 3 bearings. So there'll be that bearing that's in the existing one there, the other bearing on the other side. Then I'm going to extend it, basically make a little fascia plate on there for the little pins that couple each half, these things here, which couple these in, so center pins. So I'm gonna, actually I don't know if I need to do, oh yes I do, because I don't think there's some center pin holes on there. There's just the slots for the magnets that go in there. So I need to put a little thin plate to go on top with these same slots, and I'm going to extend this, and I've got some more dry shaft, but I'll have to nick it out of the turbine system that I built, which is over there. So I'm probably going to be dismantling my turbine thing and taking a dry shaft, or I can just take dismantle this completely, this old one, and take the dry shaft out of there. I don't know what to do yet. I think the turbine one was probably a bit of the bottom section. I think I'm just going to nick the turbine out of this bottom section. Not the top, this top section comes off like that, but I think I'll just take that dry shaft out and use that one. I'm probably going to have to cut it, you see. So I'm going to recycle that, because that bottom section wasn't really effective, really. It's kind of sad, but I'm still going to keep this top turbine that generates wind, that with it's motor driven. I'm going to keep that, but yeah, I need a longer dry shaft, because this dry shaft here isn't long enough, because I want to make this thing a lot longer, so that I've got extra I can add more coils to the system, play around a bit more with different configurations, so I can have one set of drums with one configuration, another set of drums on the other side with a different configuration, so I can compare them side by side, basically all in one system, so that one system's doing all the driving, and I could dedicate one half of it or part of it to the motor system that turns it, and then I've got extra coils to generate some milliamps. So anyway, I need to get a bit bigger, because I haven't got that many slots. I haven't really got any more slots available. I've got these 2 at the front are generating power, and the 2 at the back are generating power. These 2 on the top are not doing anything apart from trigger coil system. So these 2 at the top, this section at the top, all it's doing is sending pulses for the timing. So I'm using the top section here for the timing only, and it's not, this top section not doing any power generation really, apart from the voltages it's sending down these wires for the timing and everything. So ideally I do need I need to extend this out and make it bigger, because I only need one section for the timing. This will do the timing for everything, you see, even if it's longer. Even if this thing is 2 feet long, which it's not going to be, but it would still only need this one section for the timing. So because the timing can be used globally across the whole thing, because everything is in sync, you see. So yeah, I'm just thinking. I was thinking about putting the timing somewhere else, actually, in between the 2 sections. But I don't know. I don't know if I need to do that really. I seem to be getting good, very low current consumption, 360 milliamps to drive this thing right now, and that's at 13.8 volts DC. So it's not bad. It's not drawing out of current, and we're pushing out 672 milliamps. So I want to get more coils on here. Yeah. What else is there? I'm trying to think if there's anything else before I end the stream, because it's just a little update really. Anything else? Oh yeah, another one of them little modules arrived from China. This green thing, the one that's doing the pulse driver, this thing here that's I'm driving with this little board that I made. This little green thing arrived from China, and I stuck it up. I sprayed it with some bleach actually or something. Let's see if I can grab it. It should be sterilized now. I sprayed the whole thing with some bleach. There it is. Still in the bag. Oh, I've gone and destroyed the... it's just crap on the plastic, I think. Anyway, I was a little bit concerned about that frigging coronavirus. The screws inside look a bit, I don't know. I'm gonna have to open it, I think. Just a minute. I'm just gonna have to open the damn thing. Just give me a sec. Where's my camera stand gone? I'll stick this camera on here, phone on here. I hope it doesn't fall over. Scissors. Oh, there is a tear thing on it, but anyway, I've already... I'll take this out and have a look, because it looks a bit weird. The screws look oxidized. What the hell? I'm just scraping it to see. These screws look a bit... they're not shiny. The screws are not shiny on top. They look oxidized. That's weird. I don't like the look of them. But the rest of the board looks fine. I think the screws must be old stock or something, or they've been in somebody's box, component box. Let's just see if they turn alright. Yeah, they just feel a bit, yeah. God, that's stuck. God, that was really tight. Looks like it's been in a damp place. Very tight. You can hear it when it releases. Yeah, they're corroded. Frigging corroded. The screws. Supposed to be brand new. I got another one, even though it's pretty crap because of the other. I blew the other MOSFET out, but I repaired mine. I actually repaired mine, but I thought I'd order another one just in case. I can always put, if that blows, I'm not worried. I'll stick another PMOS on there, because the PMOSs that I've got seem to be much better. And there's that resistor. I think it's the wrong value. The one that's a pull down resistor. I had to change mine. I bypassed it. Get the magnifying glass on it. Let's have a look. Is it the same value? Ah, they've actually got the right value on there this time. 10k. So that's 10k. The other one's 10k. That's correct. The one that I had, the one that I repaired, it had a 1 meg in there. They'd put a frigging 1 meg resistor on there and that didn't work properly. But at least these have got the right value resistors on, so this should work alright. I shouldn't have to make any modifications to the resistor, because it looks like they've got the right value in there. They've got 210Ks, which is where it's supposed to be. Yeah. This does look a bit oxidized. Really, I'll show you. I'll try and get it on the magnifying glass. I don't know if I can get it on there, but look at the screw heads. Look at the screw heads. They're actually white. They're kind of white. That's oxidization, that is. I don't know if I can get it close this way. They're actually white. Instead of silver. So shiny silver. Part of it's shiny, but the rest of it, it's just the screws, the heads, that are yucky. Anyway, right. Oh. I kind of want to go and wash my hands after holding that, after it's come from China. I'm just being paranoid. Worried about this coronavirus thing and all that, you know. So, phone's falling off the stand. Right, so, not much else to show you really right now. So, the Droid 350 milliamp. I think that'll do for now. Anyway, I'll get back to you when I've got some more updates. I've got a lot of more thinking to do about things, how to do that coupling for the coils. I've got loads of steel laminations which I had cut by laser a few years back. I could use those for some kind of U-shaped stuff. I don't know. I'm just thinking about it really, about the best way of going about that. I'm in a bit of a lull at the moment. It's mainly money. Financial situation is very tight right now. I keep getting into debt, and my daughter's just had to help me out a bit because I was in a big hole. So I can't afford to get filament till next week. These kind of projects, research and development. I mean, I'm not surprised that Tesla was broke and skint. I'm not surprised that William Fries Green, who invented colour film or something, yeah, back in the yeah, all inventors struggle. They can't make ends meet. We all end up in the same boat. So I'm no different really. Even though I might not be what you would class as an inventor, really, I'm just a hobbyist. But I don't know. Maybe I am an inventor. If I created this design from scratch, maybe I am. I don't know. Anyway, whatever. That's it for now. If I can find the off button. What does keyboard come up for? Oh, hang on a minute. Where's my back thing? Is that it? I can't find the off button now. Where's the friggin'... There we are. Right. See you later. Bye.